Today we're playing with a new diode laser. Can we use it to mark steel? Let's find out. Welcome back to Cloud 42, I'm James. Well, a few weeks ago, I made some CNC plasma cut connector panels for the control box on my new CNC router back here. And a bunch of you asked down in the comments how I was planning on labeling the connections. And at the time, I just told you I was working on a plan, and I was. But now, I have a plan. And it's a freaking laser. This is an xTool D1. It was provided to me by MakeBlock in exchange for showing it in a video. Like many YouTubers, I get several email messages a day from companies that would like me to review their products. Everything from low-end laser printers and maker tools, which makes sense, to hair care products, which makes no sense at all and indicates that these people are not watching my channel. But in general, I don't do reviews, so I just throw all of those email messages in a pile, and then later, if I'm actually thinking about buying a tool for a project, I'll go back through and see if there was anybody who wanted to send me one. And every once in a while, things align, and today is one of those days. So what this is a Cartesian robot. This is all aluminum extrusion with steel rails, with steel bearing wheels that moves in 2 axes and moves a laser head that then is just on a dovetail so you can move it up and down to focus. And this actually has a pretty cool feature. It has a little arm that flips down. It's magnetic, so you can lower it, touch it to the workpiece, tighten it down, flip that up, and you're at the correct focal distance. That is actually really good design. For the rest of this is a laser diode module that has 2 laser diodes and the optics to combine those beams and focus them into one beam coming out the bottom for burning or cutting woods, plastics, and other materials. The wavelength of the light that comes out of this is 455 nanometers, and that's a brilliant blue color. Don't look at it. It's good for a lot of things. It's great for burning wood. I'm told it will cut, though I haven't tried it. I'm told that it will cut acrylic, though the 455 nanometer wavelength is not ideal for that. A lot of the energy tends to go right through without heating or burning the acrylic. A CO2 laser is much better for that. However, what the 455 nanometer wavelength is good for is it will directly mark stainless steel. I've been playing around with it, and sure enough, it will leave marks in stainless, and we'll do a little bit of testing of that today. The other thing that I found that it's good for is it will fuse marking materials like Cermark, and so we will play with that today as well. This is the bottom of the CNC control box for the new Avid router. And I made these connector panels in a previous video. These are just burned out of mild steel on the plasma table to make all of the openings that we need for all of the connectors. I find this much easier than trying to put all the holes in the box itself. When I made these, I got all kinds of comments about how are you going to label those? And I didn't have an answer at the time, but I have an answer today. Frickin' lasers, how we're going to label these. And I have already burned out some new panels out of stainless steel, and that's what we're going to be testing with the laser today. Now, these are mild steel, and I got a ton of comments when I used mild steel that that's going to rust. Well, here they are. They've been sitting in my shop here for more than a month. No rust, and if they sit here for 10 years, there still won't be any rust because I live in the desert where it's dry. Anyway, if we're going to burn some artwork into these panels with a laser, we're going to need some artwork. Let's go make some. To design the artwork, I want to start out with a model of the actual panel that the artwork is going to go on so that we have all of the openings and the general shape and just make it easier to actually create the artwork if I have a template to work from. So this is the Fusion 360 model of the actual connector panel, and I am just going to click on the surface of the sheet metal part, right click, and say Create Sketch. And now I have this sketch. I'll hit P for project, click the surface, and click OK. So now what that's done is I've created a sketch and it has outlined all of the edges of the cutout sheet metal part. which is the part that I need to put the labels on. So that'll give me a guide sketch I can use when I'm creating the artwork. Now I'm just going to rename that sketch, call it DXF Export. Now there are sketches in here that I used when I created this model in the first place, but I prefer to come back and just create a clean DXF export sketch so that if I go back and modify the model back in the timeline, I can just reproject it and have a nice clean output and not have to worry if I've got multiple sketches in here that have different parts of the design on it. So then I can just right click on this DXF export and say save as DXF, and I can save this sketch to disk, and that way I can load it into my art program and I have a template to work from. Now to create the artwork, I'm going to use Adobe Illustrator. Any vector graphics software will work. Inkscape is a free alternative, but I have Adobe Illustrator, so that's what I'm going to use. And I will just say new file, I'll make it size letter. It doesn't really matter. We're going to change this in a moment. And so I can just say file open, and I can go and load this connector panel DXF that I just saved out of Fusion. And I want to scale this where 1 unit is 1 inch. And I know that because the model is in inches. If it were millimeters, I could say 1 unit equals 1 millimeter and get this artwork in the correct size. So now I have my artwork in here and I can see that it's actually upside down. So I will just select everything and then hover here till I see the rotation. I can bring this around the right orientation. If I hold Shift, it'll lock it into 45-degree increments. Let go. Now I have that the right direction. Now you can see my artboard is the wrong size, but I can fix that. If I go back over into Fusion and hit inspect, I can measure the size of my panel, and it is 5 inches high by 10.131 inches wide. Don't ask me why, that's just where it ended up. 10.131. Okay, so I can go back over here to Illustrator. I can click on the artboard tool, double click my artboard, and I want the width to be 10.131 inches and the height to be 5 inches. And now I have an artboard. Hit Control Plus to zoom in. Now I have an artboard that is the size of my panel, and I have my panel outline on it. Now I can come in here and put text, but the first thing that I want to do is select everything here. I'll just rubber band around it, and I want to change the color of the stroke. And I'll hit plus for new swatch, and I want to just make these all red. Now the reason we're doing this is because I'm going to make the text, the borders that I put on here, and the outline of the panel all different colors, so that when we get to the laser, we can designate different colors to be handled in different ways. For example, this red color, I don't want the laser to do anything with this because this is just a guide outline. So I want it to ignore it. So I need it to be a different color than the artwork that I'm actually putting on the panel that I want to actually burn with the laser. Okay, let's put some text here. So just hit the text tool, click, and I can type whatever I want. Servo, for example. And I can change the font on this. It's my favorite font that I use for everything for my channel branding. Let's make the size a little bigger. And I can move that into position where I want it. I won't bother too much here because I have another one that I already put together with it all designed out in intricate detail. I'd also like to put some borders around things, so I will click the rectangle tool and bring in a rectangle. Of course, we need to fix that as well. So the fill, we want no fill, and for the stroke, we want that to be stroked in some color. Let's pick a color. How about black? And a width of 1 point is fine. I'd like this to have rounded corners, so I'll come up here and grab this handle, pull it down, and round the corners. So now I've got a border around that. Now these are not ready to burn. So I'm going to use the Lightburn software to actually burn this, and Lightburn needs outlines for everything. So if I come in here and look closely, you can see that what's going on is we have a path here that has a stroke on it. But what I need to do is convert this to 2 lines, one on the outside edge, one on the inside edge, so that Lightburn knows the region that needs to be engraved. So what I can do is, while I have this selected, I can come in here and say Object, Path, Outline, Stroke. And now what that's done is it's converted this to 2 paths, one on the outside edge and one on the inside edge. And we need to do exactly the same thing with the text. Lightburn doesn't know what to do with the fonts, but I can select this text object, right-click, and say Create Outlines. And now, if we zoom in here a little closer and look at this, what we have are outlines around the text as opposed to actually a text object with the font definition. Now, I have already created one of these with all of the artwork that I want. And so I have all of my text carefully placed. You can see I've pulled out some guidelines. If you turn on the rulers, you can just grab a line and bring it down and position a guideline that can help you to line up text and get everything aligned across your artwork. And I've got the colors all set. So my borders that I want to burn are all 1 point wide. I've converted those all to outlines, and they're all green. And then all the text that I want to burn is also converted to outlines, and it's all black. So I can just save this Adobe Illustrator file, and we can open that directly in the Lightburn software to control the laser. Now, for controlling the xTool D1 laser, you have a couple of options for software. There is free software that comes with the laser. It's called LaserBox Basic, and it's exactly what it says. It's basic. It allows you to import images, create basic vector graphics, and burn those easily to the laser with a bunch of presets that were designed specifically for the machine. And if what you're looking to do is burn a picture of your dog into a wooden coaster, I think that is absolutely software for you. The other option is Lightburn, which is what I'm going to be using. It's more of an industry standard software produced by a separate software company. It is a commercial software. The license for a G-code laser like the D1 is $60. I played around with the free trial, and I found that it's a lot easier to work directly with the graphics from Adobe Illustrator, and it's a lot easier to control the dimensions, which is important to me since I'm trying to make something that I designed in CAD as opposed to trying to make something that is an aesthetic object that has a certain look. And so this is the software that I'm going to be using, and we can come in here, say File, Open, and we can directly open. If we change the type down here to all supported file types, we can directly open the Adobe Illustrator file that we saved. And that comes in, and you can see everything has come in as outlines. The text, the font has been converted to outlines, and the borders have also been converted to outlines, which is exactly what we want. And you can see that the colors have been preserved. Now over here on the Cut Layer panel, we have the 3 different colors set as 3 different layers, so we can control how those are handled separately. Now the red lines, I actually don't want those to be output to the laser. I could come over here and in the output column just switch those off. You can see it sort of ghosted them a little bit in the image, and they will not be output to the laser. Except the problem with that is when I come down here and click the frame button to drive the laser around the outside of my artwork to line it up with the workpiece, it also won't be considered for that. So I do need to have that on if I want to use it for alignment. But what I can do is double click on this, come into the settings. I've got the speed set to 100 millimeters per second. I can just set the max power percentage to 0%, and it will drive around the outside of the part when it gets to that point in burning it, but it won't turn the laser on. And that's the best compromise I've found to get it included in the frame operation, but not actually have the laser try to burn it, since it really is just the outline of the part that's already cut. Now for the other 2 layers, for the text and the outlines, I have both of those set to 7 millimeters per second at 100% power, which is the recipe I found works well for directly marking stainless steel, and it also works pretty well for burning in the Cermark. And so that's the recipe I've settled on. I think for marking the steel, you could probably go a little faster. I think they recommend 9 millimeters per second, but 7 is fine, and this will allow me to have one file that I can use to burn both and compare. Now the mode is the strategy for how it's going to actually burn this. And these are both set to fill. And if we come up here and click preview, we can see what the laser is planning to do. The red lines are traversal, that's the actual movement, and the black is what it's actually going to burn. So if we click play, we can see what's actually happening, and it is moving back and forth very slowly because of course it's burning at only 7 millimeters per second, and it's going to go through and burn all of the text, and then it's going to come back and burn these outlines. And you can see that there is a tremendous amount of wasted traverse here where it's moving across the entire image very slowly at 7 millimeters per second. And this will take time estimated, it says 9 hours, 25 minutes, and 29 seconds, which is ridiculous. So we've got to make this go faster. There are a couple of ways to do that. One is to come in and tell it to move fast through the white space. So if we go here to edit device settings, there is a setting here that says fast white space scan. I can click that, set that to a faster speed. In this case, I have it set to 100 millimeters per second. And now if we preview, go back in to that same space, hit play, and you can see that it's burning. Actually, I've got it right in the middle of a line. It's moving much faster over the white space area. Now this does make it go faster. You can see it's now estimating 1 hour, 16 minutes. And this is just because of the really slow speed burning all this stuff. But the other problem that I found playing with this is that there are situations where it will wrap it across. When you get into a situation where you're actually trying to burn some of these horizontal lines, it'll wrap it across and continue moving rapidly while the laser is on. I don't know if that's a bug in Lightburn or if it's a bug in the device firmware, but in any case, you'll end up with scenarios where it's moving the wrong speed. So I don't really like that solution. The other thing that we can do though is we can come in here and change the mode to offset fill. And what offset fill will do is actually drive the laser along the defined path in a spiral to fill out the part, which for these borders is perfect. So if we go in here now, you can see we don't have all that red showing all those rapid movements. And if we come back here, we can see that what it's actually doing is it's just driving around the outside of that border, filling it in. And this ends up being a much better strategy, and you can see our total time estimate is down now to 38 minutes, 38 seconds. That's still slow, but for a part like this, I think that's acceptable if I'm just making one, and this is just in my home hobby shop. A more powerful laser would be able to do this a lot faster, but I also can't grab a more powerful laser and just go hang it on the wall when I'm done using it. Now for the text, you can do the same thing. You can fill it. You can do offset fill. I've found that when doing text, complex shapes with the offset fill, sometimes it leaves little gaps. The strategy that I found that I like the best is fill plus line, and that will scan back and forth over it to fill it in, and then it will go and outline the text to make sure you have a nice clean edge. And when you come in here and look at the details, I've got the speed set here for in the common tab, that's for the fill. And then in the line after fill, you can set the speed and power there separately. I've got the outline going at 10 millimeters per second, no need to go quite as slow. It will warn you when you start this on the laser because the speed for the outline is less. I think what they're assuming is you're going to use the fill plus line to burn in the part and then the line after fill to cut it. And so it's going to warn you that you're not going slower for the cut. But in this case, that doesn't matter. We also have some options in here to control whether you fill all the shapes at once, meaning you'll scan all the way across the part, again, wasting a bunch of time. Fill groups together, which in this case will handle it one word at a time, or fill shapes individually, which will do one letter at a time. I opted to fill groups together, and that works pretty well. And if we go in here and look, we're going to get our 41 minutes. And I am happy with that. For this laser, I'd love it if it were faster, but again, it's a small laser and speed is one of the compromises you make with a little machine like this. Okay, I think we're ready to go. Let's go out to the laser and actually mark some metal. Okay, I've got the laser set up and turned on, and you can hear the fan howling. There's quite a bit of waste heat generated in the laser, and that fan always runs, and yes, it is annoying. So I've got my piece of stainless steel that I've already cut out on the plasma and dressed up a little bit. This is just a test piece. You can just ignore this little goober down here and down here. There are reasons. Now, after playing with this some, I do know that because we're heating up the stainless steel, it is possible for it to move, and it sometimes does warp a little bit. So what I'm going to do is I'm going to screw it down to a piece of wood just to make sure that it doesn't start curling up partway through and lose the laser focus. I don't think it's actually going to be an issue, but I have seen small parts move, and so I want to make sure that that doesn't happen here. Okay, I've got that fastened down. The next thing I want to do is make sure that it is square to the laser. And to do that, I'm just going to bring out a 1, 2, 3 block, set it against the laser arm, and just try to move this until it hits nice and square. Okay, that looks good. Now we're going to use the laser crosshairs, the pointer on here, to try to find the lower left corner. And this is not perfect, but I'm going to just sort of line it up where I think that lower left corner is. And then I'm going to come over here into Lightburn and hit the frame button to go around the outside. Now, if you go in here to edit device settings, there is an offset here, and I have it set to -17 millimeters in X and 0 in Y. That tells Lightburn where the laser spot is as opposed to where the cutting laser or the engraving laser is actually going to burn. So I have that set to -17. By default, it's -16, but I did a little bit of testing where I put in a crosshair graphic and then put it on a spot, and it was in the wrong place, so I adjusted it the wrong direction first, and then got the right direction, changed to 17, and now it's pretty much spot on. So now, if I just come over here and hit the frame button, it will frame everything that's in the graphics here, and that includes the red lines that are the outline of the sheet metal. I have those set to cut at 0% because they have to be set to cut in order for the frame to take them into account, but they're there, so if I hit frame, it should go around the entire outside of that. And that was completely wrong because I have the origin set in the wrong place. Let's try that again. I come over here, set the origin to the lower left corner, hit frame. And that is not even close. Why is that not working? Oh, I have this set to not output. Let me turn that back on. Try again. There we go. Now it's tracing. That's pretty close. I'm gonna let the motors deactivate after a second, and I'm gonna move it up slightly. Try that again. Okay, that looks even all the way around. The crosshairs are just lighting the wood just on the outside of that, so I'm convinced that that's centered. We have all our parameters set up. I have my safety glasses. So let's start the burning process. I will just click Start. Yes, and now it should start actually burning. And there we go. I see marks appearing. This is going to take a little while. Okay, that is complete. Let me turn that off so it's not making noise. And let's see what we got. Oh, and look at that. there is a little bit of warpage. It's not going to be a problem once it's screwed down, but you can see it did bend it ever so slightly. And that is the result. And I have to say that looks pretty good. And you can just barely feel it. It did oxidize the surface, so I think it's just heating up the stainless steel and oxidizing it. I'm not really sure entirely what's happening, but that's a pretty nice mark. The contrast isn't quite as great as I would really like it to be. There's a little bit of shadowing from the screw heads here in the corners because I screwed up and got too close to those. But the screw heads in the final panel, when it's installed, are going to cover that, so you won't be able to tell. That looks pretty good. Let's try one with Cermark. This is a material called Cermark, and it's a black laser marking spray. And yes, the lid is covered in tape because I dropped it and broke it. And what this is, actually, I'm not sure exactly what's in it, but it goes on almost like a ceramic glaze. And so I think what it is mostly like particles of glass or ceramic that the laser then melts and fuses onto the metal, and then you rinse away everything that wasn't fused on. So I just bought a small can for testing. This stuff is not cheap. A couple ounces is a little more than $20. You can get it in much larger cans, but I didn't want to do that until I was sure it was something that I was going to want to use and it was going to work well for my applications. So I just bought the little 2-ounce can, and we're going to give it a try today. So all I got to do is just take clean metal. This is stainless steel, and we'll just put a nice even coat. It doesn't have to be thick. It just has to be even. And then we'll let it dry and go put it under the laser. That should be about it. That's probably too much, but we got a nice even coat on there so that the laser can burn that in. We'll let it dry, and we'll go give it a shot. Now, this stuff is pretty dusty, and so it's easy to get it all over your fingers. I don't think that's necessarily an issue, but we're going to just try to be careful here because I don't want to smudge it any place where I need to make a mark. Okay, that looks pretty good. Let's let her run. Turn this off so you don't have to listen to the sound. That looks pretty good. Channeling my inner Lowry Buhensilta. Okay, warp on that is about the same. Sure looks nice. Let me get a rag here. Now, in theory, the unlasered stuff should just wipe off. And sure enough, that looks pretty good. Let me go take this in the kitchen sink, wipe it all down, and then I'll bring it back and we can take a closer look. Okay, I've got this all washed off and I've got both panels here. This is the one that was marked just dry on the stainless. And you can see it's a pretty legible mark. It's kind of a gray, maybe a little bit of a brown color. And I think that's just oxidation from locally heating the stainless. And that looks pretty good. And the great thing about this is, aside from the cost of the stainless material, this is basically free. The laser just burns this in. It doesn't require any marking compound. But it is not as much contrast as I would prefer. And you can compare that to the Cermark, and this is really nice. And this, you can definitely feel it. This is tough stuff. You can't even touch it like with a fingernail. I've done some scratching up of some sample pieces because I've done a few on some other material, and it doesn't really scratch off. If you don't get the laser hot enough, it doesn't bond firmly. But once you get this stuff bonded right, and with this laser, I found that running about 7 millimeters per second at 100% laser power bonds this stuff in beautifully, and that is the result. I'm gonna go install this on the machine and see how it fits. Oh, actually, I still need to burn the smaller power panel. I'll do that, and I'll meet you over at the CNC machine. And this is the panel installed on the box. I decided to go with the Cermark one because the contrast is so much greater, and I think it looks fantastic on the box. Now, it's interesting to note that the power panel over here looks darker in the camera than the connections for the CNC, and the reason for that is because I brushed these. I used a surface conditioning tool and brushed the stainless after it came off of the plasma, and the brush strokes are going this direction on this panel horizontally, and they're going vertically on this panel. So depending on exactly where the light is and exactly where the camera is, it looks lighter or darker. So that's the only reason that this one looks dark. In your view, it's in reality just as bright and just as high a contrast as this one. And I have to say, I am really, really pleased. I honestly was not sure if a little diode laser was going to succeed with melting in the Cermark marking compound or succeed in actually marking the stainless steel directly. But I mean, as you can see, it did, and this one that was marked directly in the stainless would have worked just as well, but I really do like the look of the Cermark, the nice black. Now this stuff on where it's marked directly in the stainless, this will come off. If you scrub this with Scotch-Brite, it'll start to fade out, and you can eventually get the mark gone completely by buffing it down. It is just in the surface, and the Cermark does stand up to Scotch-Brite a lot better. This is really quite, if you get it fused, it really is quite a durable marking. Well, that's all I've got for you today. I actually have one other process with the laser that I want to try, and that is engraving in anodized aluminum. I played with it a little bit. It looks fantastic. I've got a project coming up, and we will take a look at that in a future video. If you enjoyed this video, give it a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.